Hey guys, it's Mr. Lauer here. This is just some help with this algebraic two-column proof assignment. Now today we talked about a lot of properties, and a lot of them are review, the things that you already knew. Maybe you didn't even know that they were properties, but you were doing it. So you should have this handout here. On one side it's properties of equality. There's the names of them here on the left. There's examples and like symbolically how you represent them over here, and then there's kind of like the main idea in words here on the right hand side. So properties of equality on the front, then you have some properties of addition, and then some properties of multiplication. Now these aren't all the properties of real numbers that exist, they're just some of the ones that are the most common and the ones that we're going to use. Okay, so we're going to use those properties today to do what we call an algebraic two-column proof. Okay, now we've been talking about axiomatic systems, and in an axiomatic system, a proof is just a deductive argument that gets you to a result. Okay, there's lots of ways to structure or organize those arguments, and one of the ways we structure those arguments is in two columns. In a two-column proof, we have statements on the left, and then we have a justification on the right. A justification, another word for justification, you'll see this sometimes, like I think it says this in your book, is a reason for what you're doing or what you're saying. Eventually we're going to get to the point where we're actually making arguments using theorems and postulates and things like that. But right now we're just going to practice the structure of what a two-column proof looks like using algebra as a practice. Okay? Now what we're going to do is we're basically going to solve this guy, but we're going to do it step by step, and we're going to write a reason for every step as we go. Okay? Now in a two-column proof, you will have some information given to you, and then you will have what you're trying to conclude with your argument. So this is where the argument starts, this is where the argument ends. So the very first statement in a two-column proof is always what was given to you. So I'm going to write this stuff here. Okay, and the justification for the first step is always just given. We always start with the given statement. Okay, every other justification is going to have to be a property. Now I have a list of the properties that you're going to use, or most of the properties that you're going to use up here, just as kind of a quick reference. But these properties are going to come from this as well. So this is just kind of a short list. This is the longer, more detailed list, I guess you can say. So let's take a look and see what we're going to do here. Now, you may want to have a piece of scratch paper when you do this, because in a proof, you are making statements, right? So you're showing your steps, although you're not really showing your work. So let's take a look at what we would do here. I'm going to come over here, and I'm going to kind of solve this equation a step at a time. Now, the first thing I would do in an equation like this is I would distribute that 6. And that would give me 6n plus, so 6 times 4 would be 24, equals 96. Okay, so this is basically step 1. Nothing happened. This is step 2. Now I don't draw arrows like this. I don't cross things out in my proof. It's supposed to be kind of a formal way of writing an algebraic equation. Okay, so my next statement is that next step after I've distributed. It would be 3n plus 6n plus 24 equals 69. I think I wrote 96 in my paper, but this is what it should be, 69. Okay, now the justification for that. How do I know that this is equal to this? How do I know for sure? If we were trying to convince somebody that we knew what we were doing, and they were like, okay, hold on, go back. Tell me how you got from here to here. And you're like, oh, I distributed. And you're like, well, what's distribution? You're like, oh, it's a property of multiplication that says you can do this. So our justification here is a property. Distribution property of multiplication. All right. Now next what we would do is we would combine like terms. Okay, so we got a 3n and we got a 6n. Now there's no property that's called combine like terms. Like you won't find a combine like terms property up here. So we're not saying what we're doing in this step. We're justifying how we know we can do it, basically. So I would combine these like terms, a 3n and a 6n, and that gives you a 9n. We got a plus 24, and that equals 69. Okay. Now the justification is actually maybe something that you wouldn't think about. It's just kind of a tricky one. It's called substitution. Okay. So if I had this equation, let me go back over here and show you what I'm talking about. If I had 3n plus 6n plus 24 equals 69, right? I'm basically replacing this piece with something that it's equal to. Okay. So whenever you're replacing something with something that's equal to, you can say that that's like the substitution property. So there's not, I kind of said this up here, there's not really a combine like terms property, but when you combine like terms, usually the justification is substitution property because you're replacing an expression with something it's equal to. Okay, so what I would do here is I would just say that this is the substitution property of equality. Now some of these property names are pretty long and you are welcome to abbreviate. However, when you abbreviate, you need to kind of practice being as clear as possible. For example, there's a substitution property and a subtraction property of equality. So if you say sub prop of equality, I don't know what you're talking about. Okay. Also notice that there is an addition property of equality and a commutative property of addition. So if you just wrote addition, I don't know if you're talking about this property of addition or this addition property of equality. So abbreviation is fine as long as you put enough information that it's clear which property you're referring to. Okay, next. Again, I'm going to come over here to my scratch paper. So I got 9n plus 24 is equal to 69. So the next move would be to subtract 24 from both sides. Okay. Now we don't, again, write our work. We just write the next step. So in this case, we are going to have, looks like 45, I believe. Double check that for you real quick. Make sure I got that right. Okay, 45, that's good. So that's my next step. So 9n equals 45. Okay, now what property allows me to do that? Well, I just basically subtracted the same thing from both sides of my equation to keep it balanced, right? Whenever you're balancing something, you're trying to keep your equation balanced, it's usually a property of equality because properties of equality happen when you have an equal sign, or in other words, when you have an equation. So that is the subtraction property of equality. So I'm going to do subtraction prop of equality. Okay. After that, I would divide both sides by 9 to get n equals 5. Okay. And that is the division property of equality. So again, it's one of those balancing properties. If I divide by the same number on both sides of an equation, I'm going to get another true equation. Okay. So I'm not going to show that, dividing and crossing out. I will just write my next step, which is n equals 5, and the justification will be division prop of equality. Okay, so that's a 2-column proof. Now, the reason why we do this is not to make your life harder, and it's not to make solving equations harder. It's practicing a logical structure. Later this week, we are going to be doing proofs that involve angles and proofs that involve segments and things like that. And it gets a little bit trickier when you're not used to dealing with those. So what we do is we start with something that we already kind of know how to do, and we practice justifying those steps using properties that we know. This is just to get the structure down. Now later, when we do new different kinds of proofs with segments and angles, we don't worry as much about algebra questions. And so it'll be a little bit more useful, I guess, in that scenario. So this is just practicing structure. Okay, let's do a couple more. I'm going to take a look at number 2 just because it has a division, and I think that throws people off sometimes. So we got 4 plus v over 14 and then a minus 3. And we want to prove that v equals negative 18. All right, so let's take a look. Going back to the scratch paper here. Find a clean corner. We got negative 4 equals 4 plus v over 14 minus 3. The first thing I would probably do is add 3 on both sides. Before we get too far, though, let's go ahead and write our first statement. Remember that the first statement is always the given statement, and the justification for that statement is just given. Okay. Sometimes you'll be proving a theorem, and it will say like that theorem, and then you'll have to prove it, something like that. All right. So from here, what I would do is I would add 3 to both sides. Okay. So that's going to go away. We're going to get -1 equals 4 plus v over 14. Okay. Now that property that we just used here is called the addition property of equality. Remember, when you have an equation and you're trying to keep it balanced, it's probably going to be a property of equality that you're using. So that's the addition property. Now again, when you write that justification, don't just write addition, because you're not writing what you're doing, you're writing a property. And then if you write addition, I can't tell if you're talking about the addition property of equality or the commutative property of addition or something else. So my next step here would be -1 equals 4 plus v over 14, because we added 3 to both sides. And again, that's the addition property of equality. I'm going to write add prop of equality. Okay. Now that's an abbreviation, but that's okay because I know there's no other property I can get this confused with. It's got to be the addition property of equality. Okay. It's not a property of addition, it's a property of equality. Okay. Back to the scratch paper. Okay. Next move, multiply both sides by 14. Okay. Now the property that allows us to do that is the multiplication property of equality. Again, one of my balancing properties. So 14 times -1 is going to be -14. And then I still have the 4 plus v. And I'm going to do multiplication prop of equality. Again, you can't just write multiplication there because there's properties of multiplication, like the commutative property of multiplication and the distributive property of multiplication. So we're not listing the steps, we're justifying the steps. We are writing a property that allows us to make that move, that says that that move is legal. Okay, so now we're at -14 equals 4 plus v. Okay, I'd want to get v by itself, so subtract 4 from both sides. It's going to give me -18 equals v. Okay. Again, the property that allows me to subtract 4 from both sides is the subtraction property of equality. So I'm going to put SUBTR. So there's a substitution property of equality and a subtraction property of equality, and both start with sub. So if you're going to abbreviate, don't write sub. I write sub TR for subtraction, and then for substitution I use sub ST, so I know which one you're talking about. So again, it's very, very common in proofs to use abbreviations for your properties or theorems or whatever. That's totally fine as long as you're clear. Okay, now we were trying to prove that v equals -18, and we're essentially there, right? -18 equals v. We know that that's the same thing. Those are equivalent. But there is a property that we use sometimes without even knowing it. We would probably just reverse this and say, okay, well, our answer is v equals -18. Right? Now, that's actually a property. There's a property that says that an equality statement is true, you know, whichever way you order it, and that is called the symmetric property of equality. Okay, so we got to where we wanted to. Again, I know it seems kind of picky. It seems like, well, why, you know, I can just get to the answer. The point is not to get to the answer, right? We already have the answer. The point is to justify your reasoning, to practice deductive logic, to practice the structure of chaining a bunch of statements together and say, well, if this is true, then this is true. And if this is true, then this is true. And if this is true, then this is true. Therefore, this is true, right? To make a conclusion. But in order to do that, you have to prove or support your statement with a justification. In a regular proof, that justification can be property, definition, theorem, postulate. In this case, it's just going to be properties. Okay, let's do one more. So I'm going to let you kind of handle 3 and 4, and I'm going to take a look at 5 here because that looks like a tough one. Okay. Keep in mind that there's multiple ways of doing this. You may not do the same order. You might group your variables on a different side. That's okay. So you may not have the exact same answer, but you definitely want to include several steps, and you want to justify those steps as you go. So whatever steps you do, you'll know if they're legal or not, because you'll know if there's a property that supports you, that says you can do that. All right, so once again, first step is we're going to start with the given statement. In this case, we got this long equation. All right, justification for that one is given. It's the given statement, so we don't have to justify that one. Or, well, we do have to justify it, but it's a pretty easy justification. All right, let's kind of come up on our scratch paper and brainstorm a little bit. Okay, it kind of looks like we're going to need to distribute that -2. Then we'll have to combine like terms. Then we'll have to do some grouping. Okay, so first let's distribute. -16x plus 10 plus 6 equals -4 minus 8x. All right, so this would be my next step. Let's write that out. Or my next statement, I should say. And the reason why we're allowed to do that, again, is the distribution property of multiplication. So when I have two things in parentheses and I'm multiplying outside, I'm going to distribute. So I'm going to say dist for distribution, property of multiplication. Okay, now this is not actually a property of equality. Notice I'm not balancing both sides. I'm replacing this guy with this thing because distribution, that's what distribution does. So it's actually a property of multiplication. Okay, next I would usually combine like terms. So in this case, I got 10 plus 6 equals 16. Okay, and again, there's no combine like terms property. We know that 10 plus 6 is equal to 16, so we can replace it with 16, and that's what we're doing here. So that's a substitution property of equality. Now just real quick, on some of these problems, you may have the like terms not next to each other. Okay, so let me give you an example of that. Let's say you have this, 10 minus 16 plus 6. So like same kind of idea, but these are on the other side. What you may want to do is you may want to reorder this so that those numbers are next to each other, and it makes more sense what you're doing. And if you were reordering something, that would be called, in this case, the the commutative property of addition. So when you're reordering things, that's the commutative property. All right, now this case, we don't have to do that, but some of the other problems on this, you may have to be rearranging your terms. I just wanted to kind of let you know what's happening there. So anyway, this is where we're at. This is where we're at. 16x plus 16 equals -4x minus 8x. Or -4 minus 8x. All right, so back to the proof. Statement 3. We are going to state that -16x plus 16 equals -4 minus 8x. And our justification, if somebody were to say, how do you know that that's the case? I don't buy that. You would say, look, it's a property of equality called the substitution property. So SUBST for substitution, and it's a property of equality. All right, now I'm going to need to group the x's. Now, you may decide to group them on the left, you may decide to group them on the right. Doesn't really matter. However, whatever you do, you need to justify your steps as you go. I'm thinking that it's going to be easier to group them on the right-hand side because I'll end up with less negative numbers that way. So probably what I would do in this case is I would add 16x to both sides. Let me rewrite this. This is getting a little sloppy. All my scratch work. All right, so what I'm going to do is I'm going to add 16x to this side, and I'm going to add 16x to this side. So I'm going to get 16 equals -4 plus 8x. So a positive 16 and a -8 will give me a positive 8 there. Okay, now again, we don't write the crossing out and stuff like that. We're not really showing our work. We're just going to write the next statement. So the next statement then is 16 equals -4 plus 8x. And we just added the same thing to both sides, so that's the addition property of equality. Okay. Now I'm going to want to group the numbers on the other side. So I'm going to add 4, So 20 equals 8x. This doesn't look like it's going to work out the way I thought it was. This might be a typo. Let me just double check this really quick. Negative 16. Oh, that's why. Okay, sorry. I'm going to redo this one in a different video. So I'm sorry, I made a mistake. When I copied this down on line 2, I missed that 6x. So we're going to have to take that into account. I don't want you to worry about that. I'll just put a note in the video that I made a mistake so you can skip over to the next video. Thanks.